You know, when you look up at the night sky, there is this profound illusion of permanence.
Oh, absolutely.
Right, we see these little pinpricks of light, and they just seem so static, so perfectly ordered, like they've just always been there locked in place.
Yeah, it feels like a fixed ceiling.
Exactly. But the stack of astrophysical simulations and research papers we've gathered specifically for your deep dive today, well, it completely shatters that illusion.
It really does.
Our mission today is to unpack the ultimate cosmic paradox for you. We're looking at what actually happens when two entire galaxies, each containing billions of stars, crash into each other at millions of miles per hour.
Which is just, an unfathomable amount of kinetic energy.
Right. And the tension in the research you send over, the thing that immediately grabbed me is this massive contradiction. Because on one hand, a galactic merger is a theater of absolute unimaginable kinetic devastation. But on the exact same token, it is a peaceful, almost ethereal light show.
It really is one of the most staggering phenomena we can study because you have forces at play that are so violently extreme, they can literally sterilize entire solar systems in a matter of days.
Wow.
Right? And that exists right alongside a process so incredibly gentle that a civilization might just look up and see a beautiful new glowing cloud in their sky.
Totally unaware of the destruction.
Completely unaware of the apocalypse happening just a few thousand light years away.
Okay, let's unpack this, because for you listening, to really grasp the staggering mechanics of what happens when these titans collide, we have to start with the sheer, terrifying scale of the initial impact.
Yeah, we aren't just talking about stars bumping into each other right away.
No, not at all. The first stage is this violent compression of the intergalactic medium. We are talking about the invisible outer halos of dark matter and primordial gas from both galaxies slamming together first.
Exactly. And the gravity of the approaching galaxies starts to fundamentally warp the local galactic disk.
Which is wild to picture.
It is. It takes these beautiful, familiar spiral arms that we are so used to seeing in astronomy textbooks and twists them into grotesque, elongated tidal tails.
Just ripping them out.
Yeah, tails that stretch for hundreds of thousands of light years into the empty void.
And to truly understand what that warping does, we have to look at the absolute most dangerous places in the galaxy during a merger.
Because while space is mostly empty, a galactic collision creates these massive gravitational focal points.
Right.
These are areas where the normal rules of stellar distancing are thrown completely out the window.
Right. Our notes refer to these high-density interaction zones as a lethal billiards table, which is a terrifying phrase when you're talking about suns and planets.
It's very accurate, though.
Let's ground this for a second. Imagine a celestial bowling ball hitting a perfectly balanced planetary solar system.
Okay, I like that visual.
You have these delicate orbital resonances, right?
Yeah.
Planets humming along in their perfect, predictable lanes, and then a massive gravitational shockwave just shatters that order instantaneously.
Right.
So what is actually breaking down in these specific interaction zones?
The primary thing breaking down is the statistical safety of the interstellar void.
Okay, what does that mean?
Well, normally stars are bound to very predictable near-circular orbits taking millions of years to complete. The sheer distance between stars acts as a vast barrier of safety.
Because they're just too far apart to hit anything.
Exactly. But in these focal points, intersecting spiral density waves and collapsing molecular clouds force everything together.
Ah, okay.
The local stellar neighborhood is compressed. That statistical unlikelihood of objects interacting drastically shrinks.
And that turns the local neighborhood into absolute chaos.
Total chaos.
We're looking at massive O-type and B-type blue giants here. These aren't just normal, quiet stars like our sun.
No, they are incredibly massive, hyperluminous blue stars.
And the shifting gravity of the merger violently hurls them from their trajectories. They start acting like immense cosmic wrecking balls tearing through the dark.
Imagine the sheer gravitational footprint of one of those foreign stars. It carries the colossal momentum of the entire galactic merger behind it.
Just plowing through.
Exactly. When a rogue star like that plunges through a previously stable planetary system, the interloping star's immense gravity acts like an apocalyptic slingshot.
Oh, wow.
It grabs hold of massive gas giants, planets like our Jupiter or Saturn, and just rips them from their ancient paths.
The mechanics of what happens to those gas giants are incredibly bleak.
Yeah, they really are.
Either they get ejected entirely from their solar system, thrown out into the freezing expanse of deep space to wander the dark forever as rogue planets.
Which is a lonely fate.
Very lonely. Or in an even more violent twist, the gravitational drag of the passing star bleeds away their forward orbital velocity.
Right, they essentially lose the momentum keeping them afloat.
And they go spiraling inward to be consumed by their own sun in a fiery flash of heavy elements.
It's a complete restructuring of a solar system's architecture in the blink of a cosmic eye.
Just gone.
But the reality for rocky terrestrial worlds, the inner planets where life might actually exist, is a much more prolonged, agonizing nightmare.
Because long before that rogue blue giant even enters the inner system where the rocky planets are, its immense gravity sweeps through the outer system.
Specifically the Oort cloud.
Right. And just as a refresher for you, the Oort cloud is essentially this massive spherical shell of icy debris and dormant comets sitting at the very edge of a solar system.
Trillions of them.
The passing star completely destabilizes all those comets.
Which initiates an epoch of heavy bombardment.
Yeah.
The gravitational disturbance sends all that icy shrapnel falling inward toward the host star.
Just raining down.
You suddenly have skyscapes on these terrestrial planets choked with the glowing tails of thousands of incoming comets, all of them hitting with continent-shattering kinetic energy.
And here is where I really struggle to wrap my mind around the sheer scale of it all.
It's hard to visualize.
The frequency of these impacts boils away primordial oceans, reduces global atmospheres to superheated steam and vaporized rock, and guarantees the total sterilization of any surface biosphere.
Without a doubt.
It's hard to wrap your mind around the sheer kinetic energy required for raining comets to literally boil an entire ocean away into steam.
Right.
How does that much energy just suddenly appear?
What was fascinating here is the mechanics of energy conversion. That energy doesn't just appear out of nowhere.
Okay.
It's a terrifying translation of momentum. Think about it. These comets have been sitting in the deep freeze of the outer system, harboring immense potential energy.
Right, just waiting out there.
Exactly. When the rogue star's gravity perturbs them, they begin falling toward the inner solar system. And they don't just drift.
They accelerate.
They accelerate for decades,
Yeah.
falling down the gravitational well of the host star. By the time they reach a terrestrial planet, they are traveling at unimaginable speeds. When they strike the ocean, all that gathered orbital momentum is instantaneously converted into kinetic impact and, crucially, thermal energy.
So it's not just an explosion, it's billions of megaton-level heat flashes over and over and over.
The crust of the planet literally shatters. The bedrock itself vaporizes.
That is horrifying.
The friction and heat of trillions of tons of material impacting the surface raises the global temperature past the boiling point of water.
Just from the friction of the impacts.
Yes, the traditional safety net of the interstellar void that we rely on is entirely compromised in these pockets.
But if those dense spiral arms are a billiards table, we need to look even deeper into the destruction.
We do.
Because gravity naturally pulls the heaviest, most massive material toward the absolute center of this collision.
The galactic core.
Right. And that leads us to the most violent mechanics in the universe, the core itself and the horror of direct stellar collisions.
Moving toward the core, the stellar density reaches an extreme where main sequence stars, stars similar to our own sun, actually find themselves on direct collision courses.
Which is incredibly rare normally.
Almost impossible normally. And the resulting impact is a display of primordial violence that defies our normal comprehension of physics.
Let's break down the actual physics of that. Two entire suns literally hitting each other head on.
Yeah.
A lot of people might picture two solid balls smashing together, but stars are essentially massive spheres of superheated plasma.
Exactly. It's less like two solid objects colliding and more like two massive drops of water grazing each other at unimaginable speeds.
But with way more friction.
Way more. The friction between them violently rips their outer layers of plasma away.
Wow!
When their stellar atmospheres intersect, the sheer kinetic friction and immense gravitational shearing tear away the outer shells of both stars.
Just peeling them open.
Yes. And this exposes their blazing, incredibly dense fusion cores to each other.
And that triggers what astrophysicists call a hypernova.
Right. The sudden merging of those exposed, hyperpressurized cores completely destabilizes their internal fusion rates.
Because they were never meant to touch.
Exactly. It culminates in an explosive release of energy that is orders of magnitude more powerful than a standard supernova.
Unbelievable.
This singular event unleashes a devastating, highly focused wave of gamma radiation that sweeps through the surrounding space.
And the collateral damage of that gamma wave is terrifying. let's talk about what gamma radiation actually does when it hits a planet.
It's not pretty.
We measure the blast radius here in parsecs, and just to ground that, a single parsec is about 3.26 light years, or roughly 19 trillion miles.
This massive area of effect.
This hypernova blast violently strips the ozone layers and the very atmospheres off any planets caught within a radius of dozens of light years.
Just blown away.
Yeah. Bathes them in lethal ionizing radiation that just shatters DNA and ends any complex chemistry. It's a silent and visible wave of death, wiping the slate clean.
And that level of destruction is just from individual stars colliding.
Right, that's just the appetizer.
Exactly. At the very heart of the galaxy, you have the supermassive black holes. Every major galaxy has one anchoring its center.
Like our Sagittarius A star.
Exactly like that. And in a merger, these two behemoths, each containing the mass of millions of suns, are drawn together in an inexorable death spiral.
Plunging toward a singular barycenter.
Right.
And just to clarify for you listening, a barycenter is essentially the mutual center of mass between two orbiting objects. Think of two spinning ice skaters holding hands, pulling each other toward that empty space in the exact middle.
That's a great analogy.
But these aren't ice skaters. They are supermassive black holes, and they aren't going down alone.
Not at all.
Their combined gravity drags millions of surrounding stars with them into this incredibly dense, chaotic accretion disk.
The friction within that accretion disk is incomprehensible. You have billions of tons of stellar gas, pulverized planets, and shredded stars spiraling toward the event horizon.
All just funneling in.
Yeah, and all of that material grinding together creates a massive bottleneck. It doesn't just fall straight into the black hole.
It gets backed up.
It creates a superheated traffic jam. And that immense friction ignites a quasar-like active galactic nucleus, or an AGN.
The research notes describe this central engine emitting colossal jets of relativistic particles and hard X-rays.
Yes.
Again, let's unpack the mechanics there. Relativistic particles are basically matter moving at a significant fraction of the speed of light.
Incredibly fast.
How does an AGN create these cosmic blowtorches that instantly incinerate anything in their path?
Well, the intense magnetic fields generated by the spinning black holes take that superheated traffic jam of matter in the accretion disk and channel it outward.
Like squeezing a tube of toothpaste.
Kind of, but into twin, highly focused beams at the poles. It's a mechanism of pure directed kinetic and radiative energy cutting through the colliding galaxies.
Just sweeping through the systems.
Yeah. And at the same time, the immense compression of all that raw interstellar gas into the central parsecs triggers a runaway explosive starburst event.
Right. So because the gas is being squeezed so tightly, millions of massive, highly volatile stars are born almost simultaneously in these compressed clouds.
Yes.
But because they are so massive, they burn through their nuclear fuel at a terrifying rate.
Which means they detonate as supernovae just a few million years later.
Which is nothing on a cosmic scale.
Exactly. The galactic core becomes filled with these expanding, overlapping bubbles of superheated plasma and lethal cosmic rays.
Like a minefield.
It creates a dead zone, thousands of light years across where planetary survival is physically impossible.
Wait, here's where it gets really interesting.
Oh.
Because you'd think the danger is all external. Lasers of radiation, exploding suns, raining comets. But the simulations show that a planet doesn't even need to be directly hit or radiated to be destroyed.
That's the scariest part for a lot of people.
Even if a planet somehow avoids the comets, the gamma rays, and the cosmic blowtorches, its own physical structure can just give out from the inside.
Yeah.
How does this terrifying concept of tidal bulging actually work?
If we connect this to the bigger picture of celestial mechanics, we have to remember that gravity is not just a force that pulls things in a straight line.
Okay.
It stretches them. As rogue massive objects, like brown dwarfs, wandering neutron stars, or other incredibly dense stellar remnants, pass perilously close to a planetary system, they exert a differential gravitational pull on the planets they pass.
Meaning the rogue star pulls significantly harder on the side of the planet facing it than on the side facing away.
Exactly. And this induces immense tidal stresses.
Okay.
The solid rock of the planet is literally forced to bulge and flex toward the passing object.
Just deforming the whole world.
Now imagine the friction of an entire planetary crust, thousands of miles of solid rock and mantle, constantly grinding and flexing against itself as the planet rotates through that gravitational distortion. That friction generates immense internal heat.
So the planet is essentially being kneaded like a ball of dough.
That is exactly it. And the thermodynamic result of that kneading is catastrophic.
I can imagine.
That internal heat triggers global volcanism and tectonic shearing on a scale we can't even fathom.
The ground just gives way.
Stable, ancient continents are melted from the bottom up. They're turned into churning oceans of magma.
That's terrifying.
The delicate habitable zones surrounding stars are effectively erased. Planets are often captured into unstable binary or trinary star systems.
Just bouncing between stars.
Yeah, constantly altering their radiation budget as they are dragged into erratic, highly elliptical orbits. It's absolute destruction from the inside out.
It's an apocalyptic nightmare on every conceivable level.
Truly.
But after detailing all of this, we have to pivot to the most surprising revelation in the materials you provided.
Yeah, the contrast.
Because of the fundamental architecture of the cosmos, this theater of absolute kinetic destruction is not the reality for the vast majority of the galaxy.
This is perhaps the most profound realization of the entire deep dive.
Right.
The staggering, almost incomprehensible vastness of the interstellar void means an entirely different, almost ethereal reality exists concurrently with the destruction at the core.
There's a brilliant analogy to help visualize this.
Oh, the sand grains.
Yes. The average density of stars in a galactic disk is akin to placing 2 grains of sand thousands of miles apart.
It's so hard to wrap your head around.
It is. When you picture that, just 2 tiny grains of sand separated by thousands of miles of empty space, you suddenly realize why the probability of macroscopic objects like stars and planets physically striking one another remains profoundly low across the outer arms of the galaxies.
In those vast, sprawling territories at the edges of the galactic disks, the collision of 2 titans is a ghostly, silent passage.
So for planetary systems situated in these tranquil zones, the galactic merger isn't a kinetic apocalypse.
Not at all.
It's a magnificent visual phenomenon. Over millions of years, the intruding galaxy approaches, and its sprawling spiral arms gradually fill the night sky of these outer worlds.
Just dominating the view.
It dwarfs the local moon, enveloping the heavens in a glowing, ethereal web of starlight, dark dust lanes, and glowing nebulae.
And while the macroscopic objects, the stars and planets, rarely collide, the vast, diffuse, interstellar gas clouds permeating the galaxies do collide.
Right, because they take up so much more volume.
Exactly. This is a mechanism known as a ram pressure interaction.
Let's define that. Ram pressure is essentially the drag force an object feels as it moves through a fluid.
Like aerodynamic drag.
Like the wind resistance you feel when you stick your hand out of a moving car, but happening to massive gas clouds in space.
That's a great way to think about it. When these massive gas clouds from the 2 different galaxies plow into each other, the vacuum of space suddenly has friction.
Okay.
The ram pressure compresses and heats the gas. And that heating triggers slow, majestic waves of star formation across the collision front.
Creating new stars instead of destroying them.
Yes. The interaction illuminates vast stellar nurseries in brilliant, vibrant hues of ultraviolet pink and deep blue. It's a localized explosion of creation, entirely removed from the destruction happening deep in the core.
So for the lucky worlds in the outer edges, it's less like 2 solid objects crashing and more like 2 massive clouds of smoke simply passing through each other.
The macroscopic gravitational fields absolutely interact, but you are right about the local effect.
Okay.
The overall gravity of the merging galaxies elongates the orbits of the individual stars, shifting them into complex 3-dimensional elliptical trajectories around a newly forming galactic center.
That the local architecture of those specific planetary systems, the planets orbiting their specific sun, doesn't change.
It remains largely undisturbed.
That is so weird to think about.
The planets continue their serene clockwork orbits around their host stars because the gravitational bonds within a tiny solar system are much stronger locally than the diffuse galactic tide pulling on the entire star system from afar.
So the solar system moves as a single unit.
Exactly. They are shielded by the immense distances, separating them from that chaotic gravitational drama playing out in the galactic core. The sky above them is completely transformed, but the ground beneath their feet remains perfectly still.
It's just wild to think about. You wake up, you go about your day, the gravity feels normal, the ground is completely stable.
Yeah.
But you look up, and the entire sky is filled with the glowing pink and blue gas of an intersecting galaxy.
It's a profound duality of existence in the universe.
But this chaotic mixing of gas clouds and migrating stars doesn't just put on a light show. It fundamentally changes the architecture of the galaxy itself.
It really does.
When the dust finally clears and these two massive clouds of smoke settle over billions of years, what are we actually looking at?
What is left behind is transformation and rebirth. Over billions of years of gravitational settling and chaotic mixing, the distinct, flattened, spiral structures of both original galaxies are gone.
Those beautiful arms we started with.
Completely washed away. The orbits of the stars become thoroughly randomized. They merge into a singular, massive, elliptical galaxy.
Like a giant blob.
Yeah, structured, devoid of spiral arms, shaped more like an enormous sphere or a rugby ball, blazing with the combined light of 1 trillion stars.
So what does this all mean?
Well,
when we really sit with these sources you shared with us, it's a humbling reminder that the universe operates on scales of terrifying violence and breathtaking beauty simultaneously.
it's the ultimate paradox.
The exact same gravitational forces that drag gas giants into their suns, that incinerate entire solar systems with cosmic blowtorches, and that literally boil oceans away, are the very forces that gracefully integrate surviving worlds into a boundless new whole.
Beautifully said.
For those surviving worlds deep within this new cosmic architecture, their night sky changes forever. The distinct band of the Milky Way would be gone, replaced by a massive, immersive dome of uniform, brilliant starlight.
Which raises an important question, and it's something for you to mull over as we wrap up this deep dive.
What's that?
If our human experience, our mythologies, and even our early navigation are so deeply influenced by the dark Milky Band of our current spiral galaxy,
Right.
imagine the profound psychological and cultural shifts a civilization would undergo if they evolved under a sky that was a solid uniform dome of 1 trillion blazing stars.
Wow.
With light coming from every conceivable angle, casting away the deep shadows of the void, how would a world born from a galactic collision even begin to conceptualize the dark, empty space that lies beyond?